Hello everyone. Herewith I am presenting a video lecture on corrosion topic, and this video lecture mainly highlights about the facts of corrosion, electrochemical theory of corrosion, various factors that affect rate of corrosion, as well as types of corrosion. What is corrosion? Corrosion is nothing but the gradual destruction of materials by the reaction with various environmental facts, and it may be the presence of oxygen, carbon dioxide, moisture, etc. So, this process can be defined as the destruction of materials from its surface through an unwanted chemical or electrochemical attack by its environment. Usually, metals readily undergo corrosion, which is a natural process that converts a refined metal into its more chemically stable form, such as oxide, hydroxide, or sulfide. Various facts about corrosion. So, corrosion is a natural process which readily occurs, and it proceeds through electrochemical reaction. So, whenever we mention the term electrochemical reaction, always we will come across the redox reaction, and this corrosion process always leads to the destruction of material or loss of materials, and this problem cannot be eliminated completely. Only the extent of corrosion can be minimized only with the advanced technology. Electrochemical theory. So, based on the nature of corrosion, under which condition the corrosion process is initiated, we broadly classify this corrosion as wet corrosion and dry corrosion. So, if the corrosion of the metal in aqueous corrosive environment takes place, then we call it as wet corrosion, and if the corrosion process takes place in the absence of moisture, then we call it as a dry corrosion. So, the mechanism of wet corrosion can be explained effectively by using electrochemical theory. So, as the name indicates, here the mechanism of corrosion process mainly involves the formation of galvanic cell or electrochemical cell on the surface of the metal. So, this wet corrosion takes place when the metal comes in contact with the conducting liquid, or when two dissimilar metals are immersed in a solution. So, the rusting of iron is an example for wet corrosion, where the formation of rust on the surface of iron takes place in the presence of moisture. So, this rusting of iron can be explained using the electrochemical theory. What do you mean by rust? Rust is nothing but it is a general term used for the mixture of iron oxides, which is formed from a redox reaction between oxygen and iron in an environment containing moisture, and rust is the mixture of iron oxides on the surface of iron. And chemically, if you want to define rust, it is nothing but the hydrated ferric oxide, which is also called as yellow rust, or ferrous ferric oxide, which is also called as black rust. So, the formation of rust mainly explained using this electrochemical theory. So, according to this theory, the surface of the metal or the iron mainly consists of tiny galvanic cell. So, due to the difference in potential between the two dissimilar metals, or maybe due to the presence of various environmental factor. So, there will be generation of anodic area and cathodic area on the surface of metal, and always near the anodic area the oxidation reaction takes place, and near the cathodic area reduction reaction takes place. So, this is the basic principle behind the electrochemical theory of formation of rust. We can explain this electrochemical theory of corrosion process or the rusting process by taking this diagram also. So, where you can see the representation of the metal surface by notation M, and N is nothing but the number of electrons here. So, what we can observe here, under the conducting medium, presence of environmental condition, maybe the presence of electrolyte or moisture. So, what happens, there will be generation of anodic area and cathodic area on the metal surface. So, hence there will be formation of tiny galvanic cell on the metal surface. So, here once this anodic and cathodic area is formed, the redox reaction takes place. So, as we all are aware that near the anodic area always it involves the liberation of electron, that is nothing but the oxidation reaction. So, we can observe the formation of Mn plus with the liberation of n number of electrons, and here the liberated electrons will migrate towards the cathodic area. So, what we can observe here, the galvan electrochemical cell is formed on the surface of the metal, and various reactions are possible depending on various environmental factors. So, what happens to the metal ion formed after the oxidation process? So, that will combine with the hydroxyl ion and it results in the corresponding hydroxide. In case of iron, if you are explaining about the rusting of iron, basically it involves in the formation of ferrous hydroxide. So, how these hydroxyl ions are generated near the cathodic area? So, you can see with various arrow mark the liberation of hydrogen, liberation of water, nothing but the moisture content, and the liberation of hydroxyl ions, as well as what we can observe there, the reduction or the absorption of oxygen or consumption of H plus ion. So, the reaction with respect to the cathodic area may be with respect to the presence of oxygen or the availability of H plus ion. So, in the presence of oxygen, what happens? It involves the absorption of oxygen, and finally the oxygen undergoes reduction to give hydroxyl ion. And in the case of H plus ion, under it may be under acidic condition or in the absence of oxygen, what happens? H plus ions or protons will reduces to hydrogen gas. So, always in the presence of oxygen, it results in the formation of liberation of water and hydroxyl ion, and in the absence of oxygen, is H plus ions will readily undergo reaction by consuming the electrons that is supplied from the anodic area, and results in the continuous evolution of hydrogen gas. So, this is the basic principle behind the corrosion process for all the metals, and this same electrochemical theory can be effectively applied to explain about the formation of rust. So, we know what you how this metal is corroded and how we can apply this same principle in explaining about rust in case of the destruction of iron. That is, rust is nothing but actually it is a formation of oxides of iron, that is the ferric oxide or hydrated form of ferric oxide. The mechanism of formation of rust can be effectively explained by using various steps, which mainly involves the reaction at anodic area and reaction at cathodic area, and finally the formation of rust. So, as we all are aware that anodic area always oxidation takes place. So, what happens? Iron undergoes oxidation and results in the formation of ferrous ion with the liberation of electrons. So, the liberated electron can migrate towards the cathodic area and participate in various reactions depending on the condition. So, generally what we can say, the electrochemical theory of formation of rust, when iron is exposed to the environment, according to this theory, what happens? Mainly the anodic and cathodic areas are formed, resulting in minute galvanic cells, and corrosion takes place near the anodic area by oxidation reaction, and electrons are liberated. So the electrons released at the anodic area will migrate to the cathodic area and reduction takes place. So the liberated electrons, when they move towards the cathodic area, they are responsible for various cathodic reactions. So that may be represented as follows. So the reaction may takes place in the presence of oxygen or in the absence of oxygen. So in the presence of oxygen under acidic media, what happens is H plus ions reduces to water. And similarly, under basic condition or neutral condition, the dissolved oxygen will reduces to hydroxyl ion. And in the absence of oxygen under acidic media, H plus ions reduces to hydrogen gas, and under neutral or basic condition, moisture reduces to hydroxyl ion and hydrogen gas. So if you observe the various reactions here, in the absence of oxygen, mainly it involves the evolution of hydrogen gas, and in the presence of oxygen, it involves the absorption of oxygen. So next is a formation of ferrous hydroxide. So the ferrous ions formed during the oxidation reaction near the anodic area will diffuse towards the larger hydroxyl ions to the cathodic area through moisture, and it is converted into ferrous hydroxide. Here the corrosion current starts flowing between the anodic and cathodic area through conducting media. So next one is how the rust is formed. So once this ferrous hydroxide is formed, again in the presence of excessive amount of oxygen, it will undergo further oxidation and it is converted into yellow rust, that is nothing but the hydrated ferric oxide. And in the limit amount of oxygen, ferrous hydroxide is converted into black rust, which is nothing but ferrous ferric oxide. Electrochemical theory. So based on the nature of corrosion, under which condition the corrosion process is initiated, we broadly classify this corrosion as wet corrosion and dry corrosion. So if the corrosion of the metal in aqueous corrosive environment takes place, then we call it as wet corrosion. And if the corrosion process takes place in the absence of moisture, then we call it as a dry corrosion. So the mechanism of wet corrosion can be explained effectively by using electrochemical theory. So as the name indicates, here the mechanism of corrosion process mainly involves the formation of galvanic cell or electrochemical cell on the surface of the metal. So this wet corrosion takes place when the metal comes in contact with the conducting liquid, or when two dissimilar metals are immersed in a solution. So the rusting of iron is an example for wet corrosion, where the formation of rust on the surface of iron takes place in the presence of moisture. So this rusting of iron can be explained using the electrochemical theory. Galvanic series. So galvanic series is a arrangement of metals or alloys in the order of their corrosion tendencies in corrosive environment. So series of metals arranged in their corrosion tendency order, and corrosion characteristics of metals can be studied by using this galvanic series. So here the less noble metal will experience the corrosion process readily, and this galvanic series relationships are useful as a guide for selecting metals to be joined, and also to minimize the tendency of corrosion process. So what are the characteristics of galvanic series? So if you observe the galvanic series, the chemically more active metals are placed at the top of the series. That means the metals which are placed at the top of the series are readily susceptible for corrosion process. So the metal or alloy higher up in the series, they corrode faster than the metals or alloys in the bottom of the series. So the greater the difference in their position, that means greater the gap between the position of the metal atoms in the galvanic series, then the rate of corrosion also will be faster. And if you observe, if the metals are close to each other in the galvanic series, then the tendency of a metal to undergo corrosion will be lesser. So more is the gap between the metal, more susceptible for corrosion, because the difference in potential between the metal will be more. So these are the various factors or characteristics about galvanic series and about its advantage, how we can apply in determining the corrosive nature of a metal. So we can explain this electrochemical theory of corrosion process or the rusting process by taking this diagram also. So where you can see the representation of the metal surface by notation m, and n is nothing but the number of electrons here. So what we can observe here, under the conducting medium, presence of environmental condition, maybe the presence of electrolyte or moisture. So what happens, there will be generation of anodic area and cathodic area on the metal surface. So hence there will be formation of tiny galvanic cell on the metal surface. So here, once this anodic and cathodic area is formed, the redox reaction takes place. So as we all are aware that near the anodic area, always it involves the liberation of electron, that is nothing but the oxidation reaction. So we can observe the formation of Mn plus with the liberation of n number of electrons, and here the liberated so next is about the factors affecting the rate of corrosion. How the rate of corrosion is influenced by various factors. So mainly it is influenced by the nature of the metal and some environmental factors. So in detail, if you want to discuss, we have various factors such as nature of the metal, relative areas of anode and cathode, nature of the corrosion product, and tendency to form protective film. And also it depends on the nature of the corroding medium, and the environmental factor also influences here. So we will be discussing about all these four factors in detail in our next slide. The first factor is about nature of the metal. How the nature of the metal influences the rate of corrosion. So what we can observe from the galvanic series, the metal with lower electrode potential, they are more reactive than metals with higher electrode potential. So the tendency of a metal to undergo corrosion is dependent on the nature of the metal, mainly based on the electrode potential. So as we can see from the galvanic series, the more reactive metals are placed at the top of the series. So the more reactive metals are more susceptible for corrosion, and usually tendency of a metal to undergo corrosion, it decreases with increase in electrode potential. So always the tendency of a metal to undergo corrosion decreases with increase in electrode potential. So we can take various example for this. If you consider the noble metals like platinum, gold or silver, they are less susceptible for corrosion. So they are having higher electrode potential. And if you consider the more active metals like magnesium, potassium, sodium or zinc, they are more susceptible for corrosion, because if you observe the electrode potential value of these highly active metal, always they have lower electrode potential. Next is about Next is about the relative areas of anode and cathode. So how the anode and cathodic area will influence the rate of corrosion, that we will discuss here. So the rate of corrosion at anodic area, it is directly proportional to ratio of cathodic to anodic area. So what you can say is corrosion is more rapid or it is highly localized when the anodic area is small and cathodic area is large. So why? Because when you have larger cathodic area, then it will demand more electrons from anodic area. So what happens near the anodic area? To fulfill the demand of the cathodic area, anode undergoes rapid corrosion. So you can take the example of a small pipe, steel pipe fitted in a larger copper tank undergoes rapid corrosion. So which part of the metal will undergo corrosion here? The steel pipe will undergo rapid corrosion. So here the steel part will act as anode, whereas the copper acts as cathode. So smaller is the anodic area, small steel pipe is attached, as I mentioned. So this is an example how the relative areas of anode and cathode will influence the rate of corrosion. Next is about the nature of corrosion product and tendency to form protective film. So how the product formed during the corrosion will influence the rate of corrosion. So the nature of the corrosion product plays a major role here. So if the corrosion product deposited on the metal surface or material, if it is insoluble in nature or if it is stable, uniform and non-porous, then it acts as a protective layer and it will prevent further corrosion of the metal. So if the product formed is soluble or unstable, non-uniform and porous, then what happens? The metal surface is exposed for further attack and corrosion of the metal surface takes place continuously. So you can take various example and explain this concept. If you take the example of aluminium, so what happens when it undergoes corrosion process? They readily forms their oxide. So this formed oxide of aluminium, it acts as a protective film on the metal surface and it prevents further corrosion. So similarly, you can take the example of titanium, chromium also, where the corrosion product act as a protective film on the metal body and prevent corrosion process. So for the second case, what I said, if the corrosion product is soluble, unstable, non-uniform and porous, what happens? The corrosion process will be rapid. It is a continuous process. So here the product will not act as a protective layer on the surface of the metal. For example, you can take the metals such as iron, zinc, magnesium, etc., where the oxides or the hydroxide that formed during the process, it will not form any protective film and the surface, metal surface corrosion process takes place continuously. So this is how the nature of the corrosion product influences the rate of corrosion. Next is about the nature of the corroding medium, that is one of the environmental fact where it mainly depends on pH of the medium, conductance of the medium and the temperature. So how pH of the medium will affect the rate of corrosion? So under highly acidic condition, the rate of corrosion is also high. So usually the rate of corrosion increases with decrease in pH. So if the pH is lower than 3, then severe corrosion occurs. The rate of corrosion will be highly intense, even in the absence of oxygen also, because even in the absence of oxygen, when there is H plus ion in the medium, what happens is H plus ions will consume electrons from anode and they liberate hydrogen gas continuously at the cathodic region, and this reaction Already we have discussed in the case of electrochemical theory of formation of rust, where near the cathodic region, in the absence of oxygen, how H plus ion reduces to hydrogen gas under acidic condition. So at pH greater than 10, so if you take the example of iron, at higher pH, what happens? The corrosion of iron practically ceases, and here the main reason for this is because of the formation of ferrous hydroxide. So it forms a protective coating of hydroxide of iron. Like example, you can take the example of ships that are submerged for hundreds of years in ocean. So if you observe it, they remain almost unaffected. They are not affected by this corrosion process. And also, if you consider the pH between 10 and 3, what is observed is always the presence of oxygen is essential for corrosion of iron at this pH range. Next is about the conductance of the media. So how the conductance of the medium will influence the rate of corrosion. So the rate of corrosion in dry atmosphere is less than that in wet atmosphere, because under wet atmosphere it is more conducting. So iron undergoes corrosion faster in clay than in sandy soil. So in the marine atmosphere also, sodium or other chlorides near the coastal region, if you observe, the rate of corrosion is always higher and they always enhance the rate of corrosion. So under wet condition or under the presence of moisture, the migration of the ions will be faster and rate of corrosion will be higher. And next is about the temperature fact, how temperature will affect the rate of corrosion. So always in general the rate of corrosion is directly proportional to temperature. So increase in temperature will increase the rate of corrosion. So increase in temperature increases the conductance of the medium also and results in again increase in the diffusion rate, and obviously the corrosion progress faster at higher temperature. So it will indirectly influences the effect of conductance also. So as the temperature increases, the conductance of the medium also increases. So the diffusion rate of the ions or electrons also increases. Hence the progress of the corrosion process also will be faster. Next is about the types of corrosion. So these corrosion types can be classified based on the cause of metals type of deterioration. So here we may have general attack corrosion kind, or it may be a galvanic corrosion, or it can be a localized corrosion, or a stress corrosion, or because of environmental cracking. So we have various types of corrosion here, but here mainly we are going to deal with galvanic corrosion, differential aeration corrosion, and stress corrosion. So first coming to the galvanic corrosion. So what is galvanic corrosion? So this type of corrosion is caused when two dissimilar or two different metals are in contact with each other in a corrosive environment. So this type of corrosion is also called as differential metal corrosion, or it may be also called as bimetallic corrosion or dissimilar metal corrosion. So how we can define this differential metal corrosion? So it can be defined as the accelerated corrosion of a metal because of an electrical contact. It may be a physical contact with a more noble metal or the non-metallic conductor which acts as a cathode in a corrosive electrolyte or corrosive environment. So here the metal with lower electrode potential or more active metal, usually more active metals are placed higher in the galvanic series. So they always act as anode and undergoes corrosion. And the metal with higher electrode potential. So if you observe the galvanic series, always they are placed at the bottom of the galvanic series. So here they act as cathode and they are free from corrosion. So here the potential difference, that is the voltage between the two different metal, it is the driving force for the destructive attack on the anode part. Anode part is nothing but the more active metal where oxidation process takes place and where there is liberation of electron, and the current flows through the electrolyte to the more noble metal or the cathode part, and the less noble metal always undergo corrosion here. So the conductivity of the electrolyte also will affect the degree of attack here, and the cathode to anode area ratio also influences the rate of corrosion. So already we have discussed this concept under the factors affecting corrosion, how the smaller anodic region and larger cathodic region will influence the rate of corrosion faster. So they are directly proportional to the acceleration factor, the cathode to anodic ratio. It is always directly proportional to the rate of corrosion. So for example, if we take the example of iron and copper, when iron and copper are in contact with each other in the presence of an electrolyte, then which will undergo corrosion rapidly. So always if you observe the galvanic series, as I have shown in my previous slide also, iron is higher in galvanic series. That means it has lower electrode potential, and copper it is having higher electrochemical potential, and it is placed below iron. It is placed lower in the galvanic series compared to iron. So what happens? The metal which is placed higher in the galvanic series forms the anode and gets corroded, and copper part with higher electrochemical potential act as cathode and it is protected. So metal which has higher electrode potential will be destructed rapidly compared to metal with higher electrode potential. So how you can represent this corrosion reaction during the galvanic corrosion process? So here you can see the example as I have explained, iron and copper metal, where iron act as anode and copper act as cathode. Now we will go how the reaction can be written at anode and cathode. So at anode always oxidation process takes place, where you can see the formation of Fe2 plus ion with the liberation of electron, and at the cathode the reduction of H plus ion takes place and involves the evolution of hydrogen gas in the absence of oxygen. If you observe this reaction, this is the absence of oxygen, and under alkali condition what happens? That is, even in the presence of oxygen, it results in the formation of hydroxyl ion. So this is how you can represent the reaction with respect to anode and cathode area. And next you can see one example, copper bolt fitted with steel nut. So here you can see the electrochemical series, how this stainless steel and copper is placed in the galvanic series. Now from the image what you can observe here, the steel nut that is fixed to the copper bolt, it has undergone rapid corrosion. So what you can see, the concept of smaller anodic area and larger cathodic area, and the metal or alloy which is placed at the top of the galvanic series has undergone rapid corrosion and acts as anode compared to the metal which is placed at bottom of the galvanic series with higher electrode potential. So how to prevent this galvanic corrosion? How the damage effect can be minimized? So galvanic corrosion can be prevented through various methods. So always we can select metals or alloys which are close together as possible in the galvanic series. So they are placed close to each other in the galvanic series. So if they are placed close to each other, the difference in the potential is also less, so they are less susceptible for corrosion. And also we can avoid unfavorable area effect of small anode and large cathode. So we have to design the material in such a way that it will avoid the smaller anodic area and larger cathodic area. And whenever there is dissimilar metals, so wherever possible we need to try to insulate the dissimilar metals. And also we can apply the coatings like painting the cathodic area or both the region, and keep the coatings in good condition. And also while designing we can avoid the threaded joints for materials far apart in the galvanic series. So this is how we can prevent the galvanic corrosion effectively by various ideas. Next is differential aeration corrosion. So corrosion of metals arising due to the difference in air concentration or oxygen distribution concentration on the metal surface. It is known as differential aeration corrosion. So here you can see the diagram also, where we can see some part is more aerated or more oxygenated, whereas some part is less oxygenated. So when there is difference in distribution of air or oxygen, the rate of corrosion is also affected, and it results in this type of corrosion, that is nothing but differential aeration corrosion. So oxygen is not only enables the corrosion process. So oxygen is required near the cathodic reaction always, but it will enhance the rate of corrosion also. In addition to the cathodic reaction, it will assist the process also, it will promote the corrosion process also. So the difference in availability of oxygen over the metallic surface, it will lead to the formation of oxygen concentration cell on the metal surface. So the less aerated or less oxygenated part, it starts behaving like anodic, because it has less oxygen supply, while the more oxygenated part acts as cathodic. Since the cathodic reaction involves consumption of oxygen, it involves the absorption of oxygen for the generation of hydroxyl ion. So the more oxygenated part behaves cathodic and less oxygenated part behaves anodic. The corrosions which are caused due to the formation of such oxygen concentration cell or difference in concentration of oxygen, it is known as differential aeration corrosion. So very simple, it is due to the uneven distribution of air supply or oxygen supply. So here the part of the metal exposed to higher oxygen concentration acts as cathodic region. So you can see the diagram also, where more oxygenated area is represented as cathode and less oxygenated area is represented as anode. And here the metal which is exposed to lower oxygen concentration readily undergoes oxidation. So they are poorly oxygenated region, so readily undergo oxidation with the liberation of electrons. So below the diagram you can see the reaction also, where M represents metal, where you can see N is the number of electrons. So where the oxygen availability is less, the possibility of oxidation reaction is more. And at the cathode, in the presence of oxygen, because more oxygen is available near the cathode area, so readily it forms hydroxyl ion. And this type of corrosion is usually observed in standing water, like a gutter system or metal tanks or pipes, or we have various examples for this differential aeration corrosion, mainly waterline corrosion and pitting corrosion. So next slide we will be discussing about the types of differential aeration corrosion, that is waterline corrosion and pitting corrosion. So what is waterline corrosion? So as you can see from the diagram, water storage steel tank or ship in a sea. So here mainly it deals with the corrosion process that takes place with respect to water storage tanks, or the portion of the metal which is always under water. So here waterline corrosion, it is a case of differential aeration corrosion itself, and here it occurs in ocean going ships or water storage, steel tanks, etc., where if you observe here, always a portion of the metal is always under water. And always what we can observe here is, when water is stored in a metallic tank, the metal below the water line gets corroded, not the metal above the water line. So why the metal below the water line gets corroded here? Because the metal below the water line has less supply of oxygen and it is poorly oxygenated. So obviously it acts as an anode, and the metal above the water line is highly oxygenated and acts as cathode. Hence this corrosion of metal below the water line takes place, not above the water line. So the part of the metal below the water line is less aerated, while the part above the water is more aerated. So very simple concept it is, and where it acts as anode is also clear, where oxygen availability is less, so that part of the metal acts as anode and it undergoes corrosion readily, and the part above the water line is free from corrosion because it is more oxygenated, more oxygen is available, so it acts as cathode. So always the cathode part is unaffected, anode part is corroded. So rusting is observed along a line just below the level of stored water. So you can see the example of a boat where it has affected because of this water line corrosion. So you can see the corroded part, that is nothing but the part of the boat below the water line. So it has removed above the water level and shown in the diagram. So how we can write the reaction for this water line corrosion? Was the common type of reaction, that is the oxidation process that takes place at anode and involves the liberation of electrons, and the liberated electron will assist in the liberation of hydroxyl ion, and finally the hydroxyl ion and the ferrous ion form ferrous hydroxide, and it will undergo further oxidation in the presence of oxygen to give hydrated ferric oxide, where you can see the rust formation or the corrosion process clearly. Pitting corrosion. So what is pitting corrosion? So pitting corrosion is nothing but when a metal part is covered by some dust, dirt or water droplets, the part which is covered will have lower oxygen concentration, and always the metal body which has lower oxygen concentration acts as anode, and the part which is exposed to oxygen acts as cathode. So what happens to the covered area? So they get corroded, they readily undergoes oxidation, and as a result of this a small pit or hole is formed on the metal surface. So pitting corrosion is nothing but the localized corrosion on a small area of the metal surface and results in the formation of pit or hole. So this type of corrosion is generally initiated by the deposition of sand, water drop or dust, or it may be due to the breakdown of the protective film. So for the breakdown of protective film, the environment fact also matters. So there may be some chemical species in the environment which will damage the passive film or the protective film on the metal. So these all factors will contribute or initiate the pitting corrosion. So the metal below the deposit is exposed to lower oxygen concentration, always acts as anode and readily undergoes oxidation and liberates electrons, and the metal surrounding the deposit acts as cathode because it is exposed to higher concentration of oxygen and it is always unaffected, or it is not destructed or damaged. So the corrosion starts under the dust part or the water droplet part, resulting in a pit. So the pit grows continuously and ultimately causes the complete damage of the metal. So how these corrosion reaction can be represented? So that is already explained in the previous slide, how we can explain the oxidation process that takes place near anode, and near the cathode what happens in the presence of oxygen, because it is more uh, oxygen supply area. So under the presence of oxygen what happens, there will be reduction of oxygen to hydroxyl ion, and how it results in the formation of rust. Next is about stress corrosion. So stress in the metals, as the name indicates, the stress or strain in the metal which results in the corrosion process. So such type of corrosion we call it as stress corrosion. So stress in the metal arises whenever there is a fabrication of the article, or when the metal is subjected to mechanical operations such as welding or bending, pressing, hammering and servicing process. So during the welding or the bending process, obviously the temperature of the metal body will also be higher. So these all factors will contribute for the corrosion process. But near the stress area what happens, actually the atoms of the metals near the stressed area, they always have higher energy state when compared to the metal atoms in stress free part. So when they have higher energy state, obviously they will have higher oxidation potential also. So the stressed areas are attacked more easily even by mild corrosive environment, and they readily undergo corrosion. So here this type of corrosion occurs only under some specific corrosive environment. So the corrosive agents are highly specific and selective also here. For the corrosion to occur, both stress as well as the specific corrosive environment are necessary. To occur this process, we need both stress as well as specific corrosive environment. So what are the different specific or selective agents that I mentioned? It may be caustic alkali, or the nitrate solution, or traces of ammonia in case of brass, or acid chloride solution for stainless steel. So in case of your caustic embrittlement, it is one of the problem associated with the boiler, where the steel boilers undergo corrosion readily at the stressed portion. So here whenever the tensile stress at the tip of a crack on the metal body makes the crack to progress in a plane perpendicular to the stress until the failure occurs, failure of the metal body occurs. So always it is observed that presence of stress as well as specific corrosive environment are necessary for stress corrosion to occur. So how this corrosion can be prevented? So as we have seen the preventive methods that we can follow to minimize the galvanic corrosion already in the previous class. Other than this, what other uh, concepts can be applied to prevent this corrosion process? So mainly we can minimize the environmental measures, maybe by making sure the metal surface is free from any chemical species or moisture content, so that we can minimize the rate of corrosion. Also specifically the stress corrosion can be minimized or avoided by designing the modification of the article. So with the proper designing of the article also the process of corrosion can be minimized. And also by applying the protective coating on the metal surface. So we can go for metal coating like galvanization or tinning process, where it is nothing but the protection of the metal surface by the thin film of protective coating on the surface, so that it will avoid the corrosion process of the surface of the metal. And always we need to, when we design the article, always we need to use the corrosion resistant metal. For example, we can concentrate about aluminum metal, which has less tendency for corrosion process. And also we can go for the cathodic protection method, maybe by using the impressed current method, or by sacrificial anode method. So we have two technique under cathodic protection, and always the pitting corrosion can be minimized. The rate can be minimized by keeping the metal surface free from dust, chemicals or water drops, so that there will be uniform distribution of oxygen on the metal surface. So these are all various concepts that we can apply to prevent the rate of corrosion, to minimize the rate of corrosion, also to prevent corrosion process. As a part of summary, I would like to conclude the various topics that we have discussed in this video lecture now. So initially we have discussed in detail about the electrochemical theory of formation of rust, where the mechanism of formation of rust using electrochemical theory was explained step by step, where mainly it involves the reaction at anodic area and reaction at cathodic area, where oxidation takes place near the anodic area and results in the liberation of electrons, and the liberated electrons will migrate towards the cathodic area and results in various other reactions, maybe the reduction of oxygen to hydroxyl ion or the liberation of hydrogen gas, and finally the formed ferrous ions combines with the hydroxyl ion and results in the formation of ferrous hydroxide and further oxidation of ferrous hydroxide in the presence of oxygen will form the rust, that is nothing but the hydrated ferric oxide. And next we have also discussed about the various factors that affects corrosion process. So we have discussed about 4 important factors, mainly the nature of the metal. So nature of the metal influences the rate of corrosion, mainly depending on the electrode potential value. So if you observe the galvanic series, the metal which is placed at the top of the galvanic series will always act as anode, and metal which is placed at the bottom of the galvanic series will act as anode. And about the next factor was about the rate of corrosion, how it is influenced by the nature of anodic area and the cathodic area. So the ratio of anodic area to that of cathodic area is directly proportional to the rate of corrosion. So always the rate of corrosion is higher when the metal surface, the anodic area is having smaller portion and cathodic area is having larger portion. So when you have smaller anodic area and larger cathodic area, the rate of corrosion is also more and rapid. So this is how the relative areas of anode and cathode will influence the rate of corrosion. And also we have discussed about the nature of the corrosion product and how it will influence the rate of corrosion. So once the corrosion process is initiated, the product formed influences the rate of corrosion. So if the product formed is highly stable, or if it is insoluble, or it is uniform throughout the surface of the metal, then it acts as a protective layer on the metal surface and it will prevent the corrosion process. So on the other hand, if the product formed is not soluble, if it is soluble, unstable, non-uniform and porous, then what happens? The corrosion process is further continued. So it will increase the rate of corrosion. And also the environmental factor we have discussed, that is mainly the pH of the medium and conductance of the medium and temperature of the medium, how it will influence the rate of corrosion. So always it is observed that lower the concentration, lower the pH level, the corrosion rate increases, because as the pH decreases, more H plus ions are available, so that it undergoes reduction and readily liberates hydrogen gas. near the cathodic area. So the corrosion process takes place continuously. And even the conductance of the medium, the rate of corrosion is more in under wet condition or moisture condition. So the conducting ability is more, means diffusion rate of the ions or electrons are also more. So what happens, the rate of corrosion also enhances. And even the temperature has direct influence on rate of corrosion. So rate of corrosion is directly proportional to temperature. So one more fact is that as temperature increases, conductance of the medium also increases, so the rate of corrosion also increases. So these are all the various factors that we have discussed about how these various factors will influence the rate of corrosion. And next we have also discussed about types of corrosion. So we have discussed about different types of corrosions like galvanic corrosion, differential aeration corrosion, and stress corrosion. So galvanic corrosion, which is also called as differential metal corrosion. So here the when two dissimilar metals comes in contact with each other under corrosive environment, so the type of corrosion that takes place, we call it as galvanic corrosion. So here always metal which is higher in the galvanic series. So higher in the galvanic series means they have lower electrode potential, they form anode and gets corroded. And metal which are lower in the galvanic series means they have higher electrochemical potential, they always act as cathode and it is protected. So that is a basic principle behind galvanic corrosion. Next one is about differential aeration corrosion. So as the name indicates, when there is uneven distribution of air concentration or oxygen concentration, the corrosion that results due to uneven concentration of air, that we call it as differential aeration corrosion. So here always the less aerated or less oxygenated part, always it behaves like anode, while the more oxygenated part behaves like cathode and it is unaffected by corrosion process. So the area which has less oxygen supply will readily undergoes oxidation and liberates electron, and the more oxygenated area it will consume oxygen for the reduction process and it acts as cathode. So under differential aeration corrosion, we have discussed about two different examples, that is waterline corrosion and pitting corrosion. So where waterline corrosion, it is also a kind of differential aeration corrosion. It is mainly observed in case of your water stored metallic tank or water stored articles. So mainly here also the part below the water line, that is always less aerated, and so it acts as anode and it readily undergoes oxidation process, whereas part which is above the water line acts as cathode because it has more supply of oxygen. And also about pitting corrosion we have discussed. Here it is nothing but it is a kind of localized corrosion where you have uneven distribution of air or oxygen due to the dust or the water drop or the sand or any chemical on the metal surface confined to small area. So what happens when these small area is protected by this dust particle or water drops, what happens, the below the area of this dust particle will have less oxygen supply, so they act as anode and initiate the oxidation reaction. So what happens, once the small pit or hole is formed, the corrosion process goes on, increases, and it results in the damage or destruction of the metal part. And last one about stress corrosion. So what is stress corrosion? As the name indicates, because of the stress or the strain on the article, if the corrosion occurs, then we call it as stress corrosion. And for the stress corrosion to takes place, the two factors are necessary. One is the stress on the article or the metal body, as well as the presence of corrosive environment is also must for the corrosion to take place. So here we have also discussed about different preventive technique that we can apply to minimize the rate of corrosion or to prevent corrosion. So next is about the factors affecting the rate of corrosion. How the rate of corrosion is influenced by various factors. So mainly it is influenced by the nature of the metal and some environmental factors. So in detail, if you want to discuss, we have various factors such as nature of the metal, relative areas of anode and cathode, nature of the corrosion product,